Hey everybody, today we're going to talk about similar triangles. So, when two angles of one triangle are equal to two angles of a second triangle, then the third set of angles have to be equal. Okay, so that kind of makes sense. Because I know there's 180 degrees in every triangle. So if I've got this triangle here, I know it has 180 degrees. I know 105 of them are right there. So that leaves 75, and I know 28 of them are right there. That leaves 47 degrees that has to go right here. Well, over here, it's the same thing. If I have 180 and I take away the 105 and the 28, I'm going to be left with 47, so it's also going to have to go right there. So that gives me a little theorem, gives me this theorem right here. If the two angles of one triangle are equal to the two angles of a second triangle, then the third set of angles must be equal. Now, so I can say that triangle ABC is similar to triangle XYZ. Remember, this little symbol means similar right here. And similar, again, means that it's the same shape, but maybe a different size, okay? Technically, it means all the angles are equal and all the sides are proportional. Now, normally you'd have to check to see if the sides are proportional, but with a triangle, if all the angles are equal, then the sides automatically end up being proportional. Okay, so if two angles of one triangle are equal to two angles of a second triangle, then the triangles must be similar. Okay, so decide whether each pair of triangles are similar or not. So I'll let you pause the video here, check these, see what you think. Jump back on here, and then we'll go through them. Okay, so let's check this first one here. I've got two 50-degree angles, I've got two 75-degree angles. That means that the third ones have to be the same, so X and X have to be the same. All three angles of this triangle are equal to all three angles of this triangle, so these two triangles are similar. So these are similar right here. All right, let's check this one now. So I've got a 63-degree angle, and I've got a 54-degree angle here and a 63-degree angle here. Okay, so what I got to do is I got to figure out the third angles in both of these to see if they're all the same. So if I take 180 and I subtract 63, okay, that leaves 117. And I take away 54, that's 63 degrees. So this angle would have to be 63 degrees. Well, okay, this has two 63-degree angles, this has two 63-degree angles. That means this one has to be 54. So again, these must be similar because all the angles were the same. All right, let's check this one. So this one, a lot of people look at this and they go, oh, there's only two angles here. What do we do? Well, you got a 90-degree angle right here, okay? So this one's 42. So that means this one's going to be 180 minus 90, which is 90. Minus 42 is going to be 48 degrees. So this angle has to be 48. Okay, this one's 38. So right away I know that's not the same as either one of these. These are not going to be similar. Now you might want to check and figure out that, oh, this one has to be 52 degrees right here. But yeah, they're not similar. So once you realize they're not similar, you can just write not similar. Okay, are these triangles similar? So go ahead and pause the video and try it again. Jump back on when you're done. Okay, so this one here, I've got an angle of 80 and 28 in this one. So 180 minus 80, that's just 100. And 28 right there is going to be 72 degrees. So this is a 72-degree angle. Ooh, okay, this one's a 71 and a 28, which means this angle right here is going to end up being 81. These are close to similar, but they're not similar. They're almost the same shape, but they're off by just a little bit. Okay, let's check this one here. So 90 right here, which means these two have to add up to 90. So 90 minus 66, that's going to be 24 degrees. Okay, oh, well, if this one's 24, then this one has to be 66. So these are similar triangles. Okay, you plan to cross a river and you want to know how far it is to the other side. So we're going to cross this river right here from E to D. Okay, we want to know how long is that distance. I'm going to call it X. And so you take measurements on your side of the river. So, you know, if I'm over here, I can find this spot. I can find a spot here, and I can draw this triangle. And I can extend this side to here. And then I line of sight this across to here. So I find some spot on this side of the river that I use as a sight. I can measure this is 50 feet, this is 60 feet. I know this is a 90-degree angle right here, and this is a 90-degree angle right here because I measure them to be 90 degrees. Now, I know that this angle has to be equal to this angle because those are vertical angles, and vertical angles are always equal. Okay, which means that these angles have to be equal, which means that the two triangles are similar. Okay, so I can, that's why they're similar. They're similar by all angles must be equal. So really I should probably detail that out. I explained it to you. Okay, these two angles are vertical angles. They're always equal. These two are 90-degree angles. That forces these other two angles, A and D, to be the same. Okay, so what's the distance across the river? Well, this side goes with this side. So 40 is to 50 as, okay, so this is the smaller triangle. This is the larger triangle. This is the larger triangle here. So the larger is on the bottom here. The larger has to be on the bottom here. So the smaller one's going to be X, and I just need to solve this. So this is going to be, remember we always, when you have a proportion, you always take the two diagonal numbers, multiply them together, so 40 times 60, and you divide by the other number. Okay, so I can simplify this a little bit by canceling a 0 like that, and I can go 6 times 40 is 240, and divided by 5, and then that'll go in there, what? 240 divided by 5, 48 times. Okay, so this is X is 48, and it's measured in feet, so it's 48 feet. Okay. Short little assignment today. In class, we're going to do 1 through 21 odd. I will see you guys next time. Have a great day.